I'm an experimental physical chemist and a spectroscopist by training, and so I think really broadly about two research directions in my group. So on one side of things, we develop new tools for spectroscopy, so how we can probe molecular and chemical structure and dynamics using light. But then we also, on the other side of things, are interested in using light not just as a passive probe of molecular structure and dynamics, but as a new ingredient, a new degree of freedom to reach in and change the way that molecular processes behave. So we do that in the context of strong light-matter interactions. We place molecules in optical cavities where they can, the molecule can interact really strongly with the field of light and perhaps undergo different behavior than it would otherwise. And so in that way, we're using light as this new tool to steer molecular reactivity. I was lucky because my father is a physicist and his father was a physicist. So I come from a long line of physicists. And I survived. Yeah. In fact, I had to convince them that chemistry was interesting and that what I was doing wasn't trivial. Yeah. But so I did science and math at the kitchen table with my dad, and so I think I knew from a pretty young age that that's something I was excited about. Yeah. I did several different projects during the summers as an undergrad in different fields of science, and it was really how I explored and figured out that I was a physical chemist and an experimental physical chemist. I think it's a great opportunity to try things and figure out what you're interested in and really get prepared for graduate school too. So you can go into graduate school having a pretty good sense of what you're interested in and also about what it means to really do research, which is very different from doing a problem set where there's a clear answer. Research is much more open-ended, and I think the sooner you can start to have those kind of experiences, the better. Being a new PI, I think, is a challenge for everyone. Everyone probably has unique challenges when they first start a research group. It's the first time that you're running, you're the boss. You have to do mentorship and management. You have to build a lab from scratch. You have to make decisions about research directions. And so all of that is challenging in different ways for different people. But I think it's a huge opportunity to really grow. I think it's a great experience, in retrospect at least. I also had some unique challenges because I started my group in 2020 during the pandemic. And so there were delays in instrumentation, delays in construction, challenges with hiring students and postdocs virtually. But I think we survived, and now we're coming out and excited to show the world what's going on in our group. So the advice I would give a young student just starting out in research is to figure out what you're excited about right now and pursue that. So don't worry too much about what your long-term trajectory is. Just figure out what you're excited about and where the good people are that you want to learn from right now. I think especially when you're in early days, it's really important to be able to learn from people, and so surround yourself with people who are going to teach you and show you what's exciting, and just absorb as much as you can. And also not be worried about getting into one groove of research. You can always pivot and redefine what kinds of problems you work on. I've personally changed fields going into my PhD, going into my postdoc, in my independent work as faculty. You can always pivot and find new problems to work on. So just work on what's exciting, find what's exciting right now and work on that. I think one of the biggest skills you need as a scientist is to be open-minded and flexible. especially as I've built a new group and we're trying new directions, new things that we haven't ever tried or done before, it's really important to be able to pivot when things don't work out the way that you expect them to, and to say, okay, this is the way that nature works. We're going to figure out a new way to proceed. Things aren't going to be what we expect. So I think that's really important to be happy in your work as a scientist, is to have that open-mindedness. And I also think I've found we have to be very well-rounded as scientists. So in addition to having really quantitative skills to do the research, I think having really strong writing skills and communication skills has been really important. That's how you make your work have impact, by explaining what you do to other scientists, to the broader community, in order to write proposals and really show people why what you're doing is important. I think it's crucial to have those sort of communication skills as well. I think of this as a field that's on the boundary between chemistry and physics, and I see a lot of really exciting things happening at this boundary. So in one way, we're, as chemists like myself, we're drawing a lot more tools from the physics community, from atomic, molecular, and optical physics, from laser physics, and using those tools to come and study chemical problems. And so I think there's a lot of useful sort of passage of knowledge in that direction. But also the other way, I think increasingly physicists are seeing molecules as a rich platform to do new physics, to do, platforms for quantum information, for metrology, to study physics beyond the standard model. And so I think there's increasingly over the coming years this really great back and forth between the physicists and the chemists to develop molecular quantum technology.